Hello guys and welcome back. So now we're going to take a look at this scene here, or a small project that I created to show you guys a lot of new tricks, tips and tricks in SOPs to create the scene in these wires, as well as use the wire solver to give them this natural look or have them basically fall down and overlap on top of each other. And then we're going to create animated light that travels through the curves. Let me show that. So here's an example. This is a better one. So the idea is to have some kind of light or pulses travels through. And to be clear, this project I created to teach you guys specific things. I didn't have a specific artistic goal for this or anything like that. The main purpose of this is I can show you so that I can show you specific things in SOPs and in rendering as well. So let's take a quick look here. So the first thing I wanted to point out is that these wires, if we look closely at them, they are not intersecting with the geometry at all. Okay, so they know how, see if we dive inside, none of them is intersecting with the geo. They all start at one location and then they avoid the geometry. Okay, so that's why we don't have any wires here on the back. That's because this inclination, there is no possible way for them to have this small curvature and yet be connected here. So we have to increase this curvature for them to make it around the statue. So we're going to learn that, and then all the curves are generated procedurally. So we're going to build a system for that. And then I added a wire sim on top of that after I created the curves, which this includes all the swirly motion and everything. It just didn't have this, drag feel to it. And the idea I wanted to create is to have some kind of energy source or something pulsating and emitting, having energy travel through these wires and reach another location. And I had an idea to create some kind of futuristic glass or something like that, where once the pulse reaches this, it creates some interesting patterns that maybe go up or gets connected to something else. And I wanted to have two sources, this guy and something else maybe, and they're both connected to the same screen or something like that. But this is just an idea. You guys can have anything, can create anything you want. And let's get started. So I'm not going to worry too much about the statue. I basically have a geometry that I moved and placed there. So this is the origin here. And I'm going to create a wire to start with. So I'm going to scatter some points on the statue. In this case, just one. And I'm going to create an attribute wrangle and move this point to 0, 0. Okay, so v at e is equal 0, 0, 0. So now the point is there, and we can merge these two. And use an add node to connect them. Cool, so we have our first wire there. And let's resample it. We don't have enough points to work with. Okay, and what I want to do is, this is one idea. I'm going to show different ideas that you guys can use. And this one, I'm going to have the curve travel through, and once it gets somewhere here, I want it to start and swirl or create a spiral, a circular spiral. We're going to create this all using SOPs. So I'm going to create a point VOP, and the first thing that we need to do is we need a way to convert this into a circle. Okay, so we have all these points and we want to convert them into a spiral or a circle. So I'm going to dive inside, check something super quick. Okay, and what we need to do is we need to first get a linear value that travels along the curve. and right now we have 522 points. What I want to do is I want to flip the order of the points so that the first one, number 0, starts here. Okay, I'm going to do that by simply flipping this connection, and that will change the order at which this primitives get created. Okay, and what I want to do is I want to create a linear value that starts here 0 here and ends 1 here. And I'm going to do that by taking the point number and dividing it by the total number of points. So for example, we have 0.0 here. If we divide that by the number of the total points, which is 523, we get 0. If we divide 522 plus 1, we add 1 because the point starts at 0. So if we take this number, add 1 to it, and then divide it by the total number of points, we get 1 here. So that's what we're going to do. We're going to repeat this operation to all the points. So let's add a constant to the point number. So we shift this, and then I'm going to divide this result by the number of points, which is here. So let's do a divide, and let's divide them by the number of points. But right now, the result you see here, it's an integer, and this is an integer, and the result is going to be a float. But this node is not changing that; it's giving us back an integer. So we need to convert the integer to a float, so that when we divide it, we get decimals. Okay, and now the result is correct. If we take a look at that, we should see a linear value starting 0 here and 1 here. So this is our first information. Okay, so the next thing I want to do is I'm gonna use this information as an input for a sine function. I'm gonna use sine and cosine. So I'm gonna use first a sine function with this input. I'm gonna set this to be the z component, the x component, or z, doesn't matter. So I'm going to create a float to vector, and this is going to be the x component. I'm going to connect this to p. If we zoom in, nothing is happening at the moment because the sine function is not generating enough repetitions. So what we need to do is we need to multiply the input by a constant. Let's do this. And I'm actually going to change the z component, and it doesn't matter, sorry. I'm going to change the x component, and for the z I'm going to use the point number. And let's turn this off. So basically each point now is located at 0 all the way to 1. You can see that here. And this is changing the z position. The x position is going to come from this sine function. So I'm going to connect this here. Okay, so now we have a loop. Let's set this back to 1. Let's increase it. And you can see it starts going, it starts repeating. Cool, so this is for the x component. Now I want to change the z component. Instead of using a linear value, I'm going to use a cosine function. I'm going to create a cosine function. I'm going to connect it here, same input. And I'm going to use this to be the z. And it's a perfect circle. Okay, how come this is creating a circle? Okay, let's go back. Let's actually change these two. Okay, so one is the x and one is the z. Let's let's take a look at this again. We have a linear value. We changed all the points to have an x coordinate based on their point ID. So 0, 1, 2, 3, 0 all the way to 1, 0.1, 0.2, and so on and so forth. We then take that input from 0 to 1 and run it with a cosine function. Now, the cosine function is going to start at 1, and then it will start looping. So there is a 1 offset between these two guys. So let's connect the cosine and see it starts at 1. It starts at 1. See here? And then it starts going, and if we increase this number, it's going to keep repeating. Okay? If we do the cosine function, if we drive the z component with a cosine, and then use the sine function to drive the x component, we're gonna get a circle. That's what you use cosine and sine for. And then we can decide the number of loops that this is gonna have. We can have it repeat as many times as we want, but for now we just wanted to reach there and stop. So 6.3 or something. And I don't want the circle to be perfect. I want it to scale down as it progresses. As it starts repeating over and over, I want it to scale down. And if every loop we scale it down so that the radius of the circle gets smaller, we can get a spiral. So let's add a multiply. Let's add a multiply here. And let's expose this. Let's go up. And see, with this multiplier we can shift the x and z component. So this is a global scale. And instead of using the constant value, I'm going to use the ramp that we've created. So here, this is our ramp. So the ramp starts 0, which means it scales our circle all the way to 0, and then as the value increases, we get the spiral look. Now we can increase this, and it will keep doing its spiral shape forever. Okay, cool. So we started with this curve. We transformed it into this. What if we take the original position, P, and mix it with the sine and cosine spiral in some ways? So let's add a mix. Let's connect the P with this new position, and let's see the result. Okay, so we're getting this spiral, so let's set it back to 0, we're getting our first result. And if we increase it all the way to 1, we get this the spirally look. If we set it in between, we get this result. Okay, now I don't want this to be linear, so what I'm going to do is I'm going to create a ramp. And remember, we have a linear value that starts 0 and ends 1 at the end. I'm going to use that to drive the blend here. So it's this value, and I'm going to connect this to the mix. If we go up, now we can decide where and when this transition happens. So I can set it here. I can move how soon the blend starts. So this is, it doesn't start, well, it doesn't start at all. And then as soon as it starts, start doing this. Okay, now let's do a few more things. Let's add a global multiplier to this so we can control the size of the circle. Circle radius mult. Okay, let's go up and set this to 1. And I also want to add a switch node to show either the mixed result or the deformed circle. So I want to be able to look at this by itself. So I'm going to create a switch node, and the switch is going to switch between this and this. I'm going to connect this guy, and let's expose this switcher and call it preview, for example. And let's go up. So the preview is set to 0, means we're getting the final result. If I set it to 1, I can view this guy by itself. And I want to change this to be toggle instead of 0 to 1. So here I'm going to change it to toggle. So if it's off, then we're not in preview mode, we're getting the final result. If it's on, we just view this, so that way I can work on this guy by itself. Now, one more thing I'd like to expose is this amount of repetition, and I'm going to delete that, create a multiply. Okay, I'm going to expose this. I'm going to call this iteration. let's go up, and that's 0, and then we can start doing this. Now one more thing we could do if we want to go even, if we want to control this even further, the multiplier here, we can add a ramp to it as well and control how much spiral happens along the curve. So I'm going to call this ramp spiral, just spiral. And let's set it to spline. Let's go up. So right now nothing changes, and then we can play with this value to control the shape, or how fast the spiral increases or changes. You can do stuff like this. Can increase the iterations, obviously. Okay, I want to reset this. How do I do that? Let's leave this here. I'm not going to change it for now. And then let's make sure the preview is off. And now we can decide the scale, the radius at the end, the iterations. Okay. So maybe just something like this, and we can scale this up, and we can decide where the blend happens as well. Cool, so we have, I think this is too big. Yeah, this is what I wanted, something like that. And now we have only one curve, and I want to increase this this number of points. So let's set this to 100. Okay, we have 100 points. I'm going to turn off relax. I don't need relaxation here. I'm going to set all the points to go to 0, same thing. And then with the add, we're going to connect all of them. But we're missing an attribute right now. And what we need is we need a point ID. So I copied the wrangle here. I'm going to delete that. Say add ID is equal pt9, point number. And inside the add, I can say by attribute ID. Now all the curves go there. If we take a look at this, it's not going to work well, and the reason for that is because we need the total number of points per curve. And right now the point number is not increasing for each curve, it's a total number. So what we need to do is we need to either do create our own u-coordinate and or loop over each curve by itself. So I'm going to do a loop over instead. Let's do a for each loop for each connected pieces, and this will figure out the connectivity. And let me copy that. I'm going to paste it here, and you can see now it's going to go over each curve by itself, and now we're applying that to all the curves. So let's increase the number of points. So we have 1,000 curves, and we can use a poly wire. I think it's going to generate a lot of data because the curves have a lot of points on them. So here I'm going to resample them. Actually, we can lower that here. Let's just set it to 1, something like that. And let's use a poly wire to convert these guys into actual curves. Increase the division. Cool. And now we have this. So in the next video we're going to continue sculpting this and adding more features to our curve builder. Thank you for watching, and see you in the next one. Bye bye.